Page 3 and probably 4 of the motion test. Most people did pretty well on this. Plotting these points, you just look for time in seconds, position in meters. This is time, this is position. So this first dot right there, that's that ordered pair. And then the second one, time 1, position 0. So I go across to 1 here and up to 0, which isn't going anywhere. That's my next dot. And nothing really happens in the beginning. And as I start to fill these out, I did some in between. I'm not going to do everything. That dot corresponds to a time of 5 and a position of 10. So that was this dot. And as I start to do these, you see that every second you go up, I go from 5 to 6 to 7 to 8. For every second you go up, now I'm going up by 10 meters, 10, 20, 30, 40. So this is going to give me a straight line until I get to right here. And that's at the 11 second and 80 meter mark. Hey, no, sorry, 12 second and 80 meter mark. So that dot right there is this. After that, things start to change. Instead of going up by 10, 60, 70, 80, now it's 85, and then goes up by 388, and then it only goes up by 2, and then it stays the same. So I get this curve, and it's flat. So the questions on here, write A where the sprinter was stopped. Wherever this is just flat, that's stopped. There's no movement. They're sitting there at the 90 meter mark, sitting here at the 0 meter mark. Write the letter B where they're running at a constant velocity. Remember the straight line, that's constant velocity. So right in there. And they have to be running. So this is constant velocity, but not running. C where they're speeding up, an upward curve is speeding up. D where they're slowing down, downward curve is slowing down. So upward curve, downward curve. You can move on. I'll do a little more. All right, with the problems. So sometimes you have that for t, sometimes you have that for t. Why would you use this instead of that? Well, look at what's in there. This, to get t, you have to multiply 2 times distance divided by acceleration, then take the square root. Here you have to divide distance by velocity. So you would use this when you have acceleration and distance, and you would use this when you have distance and velocity. Pretty straightforward. Another way to say it, when there's acceleration, do that. When there's no acceleration, do that. This is a straightforward math problem. Ooh, you know what I need to do? I'm going to tear out my key equations here. So I can keep referring to this. So in the problem, I've got a velocity and I have a distance. So, and I'm looking for how long, so I'm looking for an amount of time. Look, here's a time formula, here's a time formula. The only one that has distance and velocity is that one. So time equals distance over velocity, 700 divided by 3 is 233.3 seconds. Rock falls from the edge of a cliff, hits the bottom 14 seconds later. How high is the cliff? There are a number of problems that have something falling. This is another free fall problem. And with free fall, you've got to remember that. Automatically, just as soon as you hear about something thrown into the air or falling or, yeah, I guess that's it, thrown into the air or falling, just go ahead and write this down because you're going to need it. The only other bit of information in the problem is this. This is a time. It takes 14 seconds to fall. The question is how high is the cliff? So it's asking you for distance. It's not asking you for velocity or acceleration or time. What formula? Well, I'm looking for distance. I know this because I wrote that down right away. And I know the time. So I'm looking for a distance formula that has acceleration and time in it. And got that distance formula, that distance formula. This is the one. The other one's velocity and time. So write down my formula. I just copied it down. Now I'm going to substitute the distance, or sorry, the acceleration and time in there. 1/2 times the acceleration, which is -10 meters per second squared, times the time squared, which is 14 seconds. And the proper order to do this is first square that, multiply it by itself. You can multiply these together and get a number, and then those two things, you multiply those together. So this is -5, that's, oh, I don't know what 14 squared is, but anyway, multiply -5 times 14 squared and you get -980. That's the distance it traveled, and it's negative because the distance is a downward distance. If it had been going up, hopefully we would have gotten a positive answer, but we just got a negative. It asks you how high the cliff is, so don't say it's -980 meters. That doesn't make any sense. Just say it's 980 meters high. Number 3, car's accelerating from 0 to a high rate of speed in a time of 6 seconds over a distance of 90 meters. On average, how fast was the car moving? It doesn't really ask how fast it was accelerating. It just asks how fast was it moving. So it's not asking for acceleration. It's not asking for time, distance. It's asking for velocity. So we're looking for a velocity formula that has time and distance, and it's the first one we learned. Velocity is distance over time. That's the. There's also this velocity formula, but it asks for acceleration. So velocity is distance over time, and the distance is 90, the time is 6. Just substituted that for d and that for t, and I get 15 meters per second. This next one, this is just a straightforward math problem. We've got a car going 600 miles, and it's going 65 miles per hour, and it says there's a constant rate. That's important. Everything's really straightforward, except this seems a little tricky. You're asked for acceleration. You can't really figure it out except that it says it's constant, so there's no acceleration. That's how you know it's 0. It's actually kind of weird to put that in there at all, but it's in there, so you have to answer it. The formula, so let's see, distance, you just write it down. Velocity, just write it down. Then you're looking for time, so you look for a formula that has, it gives you t, and it has d and v in it. I've got this formula for t, that formula for t, that one. The only one with d and v is this one. So t equals d over v. This is the distance. This is the v. 9.23 hours. That's it.